10 years ago today, a groundbreaking discovery shook the world of physics. Gravitational waves were detected for the first time, proving Einstein right a century after he predicted them. This moment marked the start of a new era in astronomy, allowing us to hear the cosmos like never before. In 1915, Albert Einstein's theory of general relativity revolutionized our understanding of gravity. He proposed that massive objects warp the fabric of space-time. When these objects accelerate, say two black holes colliding, they create ripples that spread across the universe. Einstein called them gravitational waves. But even he doubted we could ever detect them. The distortions are smaller than a single atom, nearly impossible to measure. In the 1970s, MIT physicist Rainer Weiss proposed a clever way to detect these tiny ripples. Using a device called an interferometer, a laser beam is split into two paths, bounced off mirrors, and recombined. Normally the beams return perfectly in sync, but a passing gravitational wave slightly stretches and squeezes space, changing the timing of the beams. This shift is minuscule, thousands of times smaller than a proton, but measurable with precise instruments. Weiss, along with Caltech physicist Kip Thorne, realized that two long, widely spaced detectors could confirm a cosmic signal and rule out local disturbances, like earthquakes or traffic vibrations. By 1990, the Laser Interferometer Gravitational Wave Observatory, LIGO, was approved. Two massive L-shaped detectors were built, each with arms 2.5 miles long, in Hanford, Washington and Livingston, Louisiana. For years, the detectors found nothing. Scientists upgraded the instruments to be more sensitive, protecting them from vibrations caused by traffic, planes, and even distant earthquakes, in order to detect the faintest cosmic signals. Then, in September 2015, the upgraded instruments were switched on. On September 14th at 5:51 a.m. EDT, both LIGO detectors recorded an extraordinary signal, a clear chirp from spacetime itself. The waveform matched what Einstein had predicted for colliding black holes. The signal was so tiny it was 1,000 times smaller than the diameter of a nucleus, yet unmistakably real. Analysis revealed that the waves came from the collision of two massive black holes about 1.3 billion years ago. Europe's Virgo gravitational wave detector confirmed the same event, marking the first direct observation of gravitational waves. This discovery was announced publicly on February 11, 2016, confirming Einstein's century-old prediction and opening a completely new way to observe the universe. Since that first detection, LIGO, Virgo, and Japan's Kagra detector have identified around 300 cosmic collisions, including triple black hole mergers, black hole neutron star collisions, and a faint gravitational wave background pervading the universe. These observations have confirmed predictions by Stephen Hawking and linked quantum mechanics with general relativity in ways previously unimaginable. The scientists behind this monumental achievement, Rainer Weiss, Kip Thorne, and Barry Barish, were awarded the 2017 Nobel Prize in Physics. Their work transformed gravitational waves from a theoretical curiosity into a powerful tool to study the cosmos. From black hole collisions to the echoes of the early universe, these ripples are helping humanity explore phenomena we could only dream of observing a decade ago. Gravitational waves have changed astronomy forever. By listening to the universe, we are now witnessing events that happened billions of years ago, uncovering the secrets of black holes, neutron stars, and the very fabric of spacetime itself. Thanks to the vision of Einstein, Weiss, Thorne, and generations of scientists, the cosmos now has a new voice, and we are finally listening.